just to start, hello everybody. I'm pleased to make a presentation for this event. I will just share something that is not related directly to the presentation, something that I learned recently with my computer. So I don't know how many of you are using a MacBook. I've got a MacBook from 2 years ago, and I had some very bad issue of performances lately. In my mind, it was like maybe Slack or maybe another application that was the issue. And finally, in my mind, it's pop up actually that maybe it's a problem of throttling and temperature, because it was always happening with a hot summer day that was started like 1 month ago. And so just to let you know, the issue is just that maybe if you've got the same problem as me and as my colleague, that your fan is full of dust. And it's very simple to check what's happening actually with the Mac. If you don't have a M1 chip, so if you've got a older Mac, you've got the Intel Power Gadget tool that you can install and check if you I don't know if I can show you. Maybe I can show you like that. Okay. So if you can see my screen, this little tool can show you the frequency of your CPU, and can show you the temperature and the frequency. So when your computer is getting hot, the frequency is dropping. And for me, when it was like building with Android Studio transit application, it was like going to 1 gigahertz. So the computer was almost not usable anymore, and it was awful. So I cleaned my fan, and now it's maybe when I'm building with Android Studio, it's going to 2 gigahertz, and I still can use my computer. So a little tip for you: just open your computer and blow the dust from your fan. So maybe you will learn something. Go back to the presentation. So benchmark. It's something that I maybe fantasized for a long time. It's okay. I was just checking the chat. Okay. So some issue with the USB-C charger. Mac. So for the benchmark part, it's always something that I wanted to do to improve the application I'm working on professionally. So it's having tool to measure, and especially a benchmark tool. And why that? Because it's difficult to have the feedback of how your application is the behavior of your application. We work in debug most of the time, and we've got sometimes you've got issue, and what you can see is customer feedback. So you go on the App Store and Google Play Store, and you can see some comments and saying that the app is very slow and it's so too low, and there's some junk. And you've got a 1-star review and say, okay, it's super slow and it's not working properly, and go on and go on and go on. So, and it's always like 1-star or 2-star review, and I can understand people are frustrated with that. But what can we do as developer? So the important thing is to measure how your code is performing, and having great tools to do that. So we've got Android is not new; it's more than 10 years old, and we've got a bunch of tools at our disposition to make this measurement and to help us improve our code. So we can check, for example, the rendering tools, and that you can have directly on your phone. You can go in the developer settings and activate the overdraw and the rendering graph overview. You've got now, I say now because before it was tools that were outside Android Studio, but you've got the Android profiler that they make a great job to centralize the tools and have a nice UI and a practical way to create new traces. And you've got also the improved systrace tool that is now outputting the trace in the Perfecto tool. For people who are working with the NDK, you've got SimplePerf, and now we've got the trace.h tool to help us having better trace. And so 2 years ago, the Android tool team presented us the Jetpack benchmark library 1.0 at Google I/O. So when I saw that, I said, "Oh, exciting! We've got a nice way to do benchmark." And yeah, I was pretty excited, but I did not use it actually. So it was outside, but I didn't have the time, the occasion, nor the occasion to try that. And yeah, it fall apart in my head, and I forgot about it. And so this year, they release a new version of the benchmark tool, Jetpack benchmark tool, that it's Jetpack benchmark 1.1, and they introduced the MacroBenchmark tool, and they rebranded the original benchmark tool to MicroBenchmark, so to have the difference, and to I think it's easier this way to talk about that. So what I would say, if you've got something to learn about that, about the benchmark tools, it's the magic, I would say, is the way that is measured with a repetition. So what it will do, it run the code that you want to measure in a loop, and having like some nice way to avoid I don't know, to have other factor, having impact on the measure. And what it's doing, it's running the code on the device. So now you've got a nice way to see how your code is behaving directly on the device. And yeah. So for example, the micro benchmark, it's just have a benchmark rule that you add to your test and run the measure repeated block. And then in the block, you can just call your methods. One side note about the micro benchmark is that you have to test your code in a module. Actually, when you go in the documentation, they say, oh, if you want to test the code directly in the app, you can do it. I never managed to achieve that. So the good way, I think, and maybe it's like in the documentation, but the good way is to have your code that you want to measure in a library module, Android library module, so not in the app module. And you will create a benchmark module that will depend on the modules that you want to benchmark. For the macro benchmark, what is nice is that you don't need, an extra, I would say, a library module to test your code. You have to create a macro benchmark module, but it can directly launch the app. So it's the idea. The macro benchmark is running the app like a functional test or Android test, and the micro benchmark is most like a unit test, and it will run just a piece of code that you want to benchmark. So now, so it's what they want to sell. So say with the version 1, it's okay. We give you the tool to write your performance benchmark code and have a result quickly. Because if you try to do some benchmark before this tool, it was what making your own code to trace and to have like maybe output in a file or in the console, just doing some time measurement between the start of your call and the end, making that by end, and finally, how do you part that? So you have to create your own. You had to create your own tool to do that, and it was not very practical. I would not say it was not feasible. It was feasible, but you had to do a lot of work on your part. So there is from the documentation. The idea is to ensure that the measurements are accurate and consistent. And you can also run it directly in the Android Studio, but I think the best way is to have it integrated with your CI tool and check, I would say, release after release if you've got some regression. And I will share it later, but there's a very nice post about that. We will talk about that later. So the benchmark, so it's a MacroBenchmark API. You've got some stuff for the clock stabilization. This one, I think, I don't want to be wrong, but I think it's only if you've got a rooted device and you can set the clock to be fixed and to avoid, it's very close from what I was saying earlier with my MacBook and with the throttling with the temperature. So if you are running benchmark, so it's basically running your code in a loop, and for sure your device CPU will go warmer, and when it's too hot, it will throttle down the frequency to avoid it basically burning. So it will have an impact on the benchmark. So the idea with the clock stabilization is like you run your code at a lower frequency CPU, and it will avoid the temperature to be too high and avoid throttling and have impact on the results on your phone. Sadly, I didn't take the time right now to root my device, so I don't know what's the impact really of the throttling when I test the benchmark API. But it's a good thing to know. I think if you want to be very precise, you have to do that on the rooted device. What is nice, it's integrated. It's a lot of things that will help you to have, more stable benchmark. For the CI integration, you've got a JSON output that is done by the API. And you can also check directly in Android Studio the results. They updated the benchmark library at Google I/O. So this year, I was saying, and now we've got a bunch of other tools at the MacroBenchmark. So I will go quickly over that. This one was an update from last year. They improved the library. They fixed some bugs. So I would say that there's a release every year. Every year we've got improvements for Google I/O on the library right now. It's like for 3 years. So it's maybe too quick to make an assumption that we will have a new version next Google I/O, but we'll see. So if we compare benchmark and MacroBenchmark, we'll just read that. Sorry guys, but it's the documentation, but it's important. So the benchmark, I was just saying, it's to measure individual functions, like a unit test. And the macro benchmark is like launching your application and scrolling through a list, through a scroll view or a recycler view. Yeah, the benchmark API is pretty fast when you want to test your code. It's very quick. But the macro benchmark, as it's like repeating the launch process of your application and doing some trace behind, yeah, it can be pretty slow. It can take several minutes. So just to be aware, it's not the same tool. And you can both have the tracing done with the benchmark and macro benchmark, so it's good. So for the minimum API, I think it's just for the module that you need to have the API 29 for macro benchmark, but your application doesn't need to be 29. I think it's weird because I use it on an application that is yeah, with the older API, it's working. So I think it's just to say, okay, your module needs to be in API 29. So question, do we benchmark everything now? So we've got this tool and we can use it like crazy, and I want to measure everything, every function that I use. I want it to benchmark and have my graphs and my regression. That I would say, okay, calm down, it's a tool. And like every tool, you have to use it properly. And if we check the documentation, what it says, we recommend to provide your code that is to provide the code before writing benchmark. So the idea is you will not create a benchmark for every method that you've got in your code, for sure, but you have to decide what to benchmark. And the idea is you will find in your code some bad function, and it's the code that you will decide to benchmark. Another important thing from the documentation, it's you will benchmark only code that you run several times and many times in your app. So something that is running in a loop, or like something that is parsing some files, some JSON, or I don't know. So don't benchmark something that is called just once and that is pretty quick, and you call just when you click a button. But so you will benchmark like scroll code that is run in a scroll view or recycler view, or something that is yeah, called in a, I don't know, a gaming loop, for example. It's a good thing. So step by step, how does it work? So you will take your application in production mode. So you get your application from the Play Store, and you play with that, and you will see some jank sometimes. Because I say take your application in production because I know it for a fact. We're working with the debug application all the time, and sometimes you can see some jank and you go crazy. But when you tried your application in production, finally the jank is not there anymore, because the compilation and the work that is done behind during the with the compilation will change the speed of your app actually, and some stuff that is slow in debug will be perfectly fine and not noticeable in production. So don't waste your time with some jank that you can see only in debug, and focus on some the jank, the actual jank that people are experiencing in real life. So you play with your app, you can see the jank, some jank, you can see some slow execution, and some garbage, I would say, some issue in your app. So you will not cry, and you will just check the trace. So it's a troll for sure, but no, it's not a troll. You will check that. You will start with the trace and find the method that are expensive in your application. So it's pretty simple. It's with the Android profiler. I think I want to show you. Yeah, I want to show you how it's done. So benchmark sample. So we can see we just load profiler. We just load. I don't know if you can see. So with the profiler, I don't know if you're familiar with that, but I would say maybe not. You can start a new profiling session. I've got my Pixel 3 connector right now, but you can also load from file. So I don't know, some other developer maybe in your team did some trace, added to a ticket, and now you've got some food to work on. So I will just show you how it's done to load the file. Go in benchmark, and I've got a older trace that is from April in my back. And it's just the same trace, actually. I just opened the trace that was already open. And so it's a trace from a weird application that I made. It's like an ant simulation. I just simulating the way ants behave with the computer simulation. I would just wanted to have fun. I think fun with Kotlin and fun with I don't know, see you know, what the limit of the device, because I was just using simple draw code on the canvas, so it's not using the GPU or anything. It's just doing like raw drawing. So, and the way I implemented it was not pre-optimized. So I did some basic stuff without, you know, trying to be efficient. And the idea behind was to use the benchmark API. So there I've got a trace, and I can see in my loop that I've got the orient toward method that is taking a lot of time. And when I'm saying a lot of time, you can see like it's taking like 57 milliseconds to run. And so all my loop, it's like more than 100 seconds. So I'm skipping a lot of frame here. It's very bad, but I've got a lot of object on the screen. It's ant simulation. I've got thousands of ants, and it's working with pheromones. I've got a lot of objects to consider. But the idea is, from this point, what can I improve? And so now I've got after that, this method is taking a lot of time. I can check it, and I can write a benchmark for that. So I don't know if we can zoom a little. Oops. It's not working. I don't know. I wanted to show you. Sometimes it's bugging because we can usually move in the trace with the WASD key, but it's not working there. I don't know. Anyway, it's not important. The idea is that you will use the trace output to find the bad method and work on that. So going back to the presentation. So you've got some decision to make to find a way how to trace your application. So what you will do to trace your application. So what I did for this example, it was just in the middle of the application. I was just waiting that my application was running slow. I can show you screen copy. So if I go back, I can show you what I'm talking about, just to be sure. If I don't, so it's just a simulation of ants. I know I have no food visible here, but it's just ants seeking from food, and when they find that they bring back to the nest. What you can see just on the right here, it's the enter finding food. I'm just not drawing the food yet. And with the time, there is a lot of little dots. It's pheromones, and it's why my application is running slow, I think. So yeah, just to now that you know what I'm talking about. So to find what's going on, I waited to my app to go slow, and I just launched a systrace from Android Studio. But you know, you can't always do that. So sometimes you've got as the review that I was showing at the start of the presentation, you've got some jank at the startup. So you can start recording with Android Studio. They added the functionality, I don't know when, but it was not always there. So you can specify that you want to run a trace at startup. So you go in the run debug configuration, and you will check this box on your app and say that you want to start recording on startup, and you will specify what kind of trace you want. If you want the system calls, or you want to sample some method in Java or in C++. Oh, I've got some animation now. Okay. So the slow app startup you can do as I shown, but now with the MacroBenchmark, you've got another way to do it. So you can actually program it, and it will, as I was explaining earlier, run the startup sequence several times and show you the different trace results. It's all done automatically, and it's pretty neat. What is good with the MacroBenchmark, I would say, it's sometimes people say, "Oh, I've got some junk" when I launch the app, and you're launching the app, and most of the time you don't have any issue. And if you want to check that, and you have to run traces and after traces manually, it's very cumbersome and not very nice. With the MacroBenchmark, what is nice is you can say, okay, I will launch the application maybe 10 times or 20 times. And when you've got the result I will show you later, you've got the extreme. So it will say, okay, the quickest was that, the medium was that, and you've got the extreme, the worst case, what's this trace. And you can check on the worst case is what you want to check what's happening. So we've got some example that was shared by Google developers. So if you go on this link, you can see there's a nice repo with different type of benchmark. They got example for this the MacroBenchmark API and for the new MacroBenchmark. So it was released late, so it's saved 23 days now. It's 25 maybe. Anyway, so it's a good way to start because there's no so much documentation, I would say. So directly in the code is where you will find information. So just some documentation from the project. We say in the MacroBenchmark, what it's testing, it's just a simple startup or just a simple startup with a list in the activity, and also a scroll in a recycler view, and there you can check the jank. Okay, we're checking the, oh, okay, it's 30. Once the culprit is identified, if the code, it's the idea. If the code is running in a method that is called multiple time, a loop, a scroll, a passing, etc., there you can add a MacroBenchmark to measure repeat the code. If it's, as I said earlier, I will repeat myself, but it's important. If the code is just run once, the MacroBenchmark API will not help you really, because as it's running the code in a loop, the code will be optimized, and it will use the JIT optimization, and So you will not have a good feedback on the way you are improving your code when you do the changes. So if the code is run in a loop, you will add a MacroBenchmark and you will do some modification on your code. What I would say is like have two versions of your code, the old one and the new one, and just compare the result when you run the two codes. And for the power user, when you've got that, you can run your benchmark in CI. So there's one Medium article that is very nice, and there's very sexy, I would say, when you see that, say, okay, I want that in my application because it's pretty sweet. What it's showing there, okay, you can run the different benchmark through time, and when you see that, say, okay, but I've got a lot of information, and how can I find if I've got regression? When you see this kind of graph, it's kind of, yeah, thank you. And what they done, and what I find is nice, it's they've got a nice snippet to make sense of your results. So you will run your benchmark results through a method that will say, oh, after a while, after like different iteration, there is a regression or there is improvement. So it's not directly when you introduce the bad behavior that you will have result, but after a few run, I would say, I don't know if you will run every new merge in your base branch, or maybe every release, I don't know. But the idea is that you will have some report at the time and saying, oh, on your benchmarked methods, you have some regression. And it's done, you can do that with the MacroBenchmark, and from what I saw, you can do that with the MacroBenchmark also. So the conclusion for the benchmark and the CI integration is from the article. It's, you want to capture key scrolling interface in benchmark. So when you've got important interface that got scrolling view, and I think every application have this kind of UI. If you, yeah, it's not a game. Yeah, and for the expensive CPU calls and key library interaction. Important, it's funny, but if you will have report if you got improvement in the result. So it will run the benchmark at every iteration, and you will have report even if you've got improvement. So at least you can automatically see if what you've done have improved your application, or you can see sometimes just because maybe you updated a library dependency, it will improve the performance of your code. So it's good to know, just for science, I would say. Yeah, it's important. Yeah, this one I did a note, but I spoke about it earlier. So important, if you're doing some benchmark, run it on the same device, and run it on a rooted device where you keep the clock. What can it's 10? We've got 10 minutes. I can show you the benchmark, actually how it's working with the sample application, so that you know where to find that, and you will know how to play with the code. So I will open the benchmark again, and I will just show you the code. Maybe I have to show it in presentation mode. We check. No. Preference? No. Okay, it's better. Right, project. There I can show you the code. Maybe I'm not obliged to do that. I don't know. Just tell me in the chat if you can see when the code is tiny, because actually I have to see the result of the benchmark. So in the code sample, you've got like a UI module and just a benchmark module. The benchmark module just have the Android test package where you've got the different benchmark that will test against the UI module. So it's kind of dummy tests. So there is one test, for example, that is testing the autoboxing with the integer that were lower than 100 and higher. So it's some stuff that we know because we read about it and we know how it's working. But what's nice, I would say, it's you can now test against it very quickly. So you've got some assumption of how the framework is working, how the language is working, and how the different API are working. But sometimes just assumption. You say, oh, I know that if I use this kind of linked list, for example, in this case, it would be quicker to do, I don't know, insertion and deletion. But sometimes, now I can test against it and verify that if my assumptions are good and if it's, I don't know, if it's working well in my case, actually. So for that, I will try to run this one. I don't know if it will appear. If it's not appearing, okay, we can have the results. So now you can see that it was very quick to run it. And it was just 2 seconds. And I've got the result there. So it's in nanosecond that the results are visible. So it's not really the time that it will execute on your application in real life because they've done a lot of stuff to avoid, as I was saying earlier, throttling and some I don't know. It will be probably quicker when it executes in real life situation, but the importance there you can compare your modification. Actually, two way to do things. You will compare that, and you will see what is the better. So don't say, oh, it will take 37 nanoseconds to run the integer allocation versus 21.1 for the cache allocation. It's not the real value, but you can say, oh, it's almost twice the time, to use one over another. And yeah, it will be an help to making choice or to improve your code. You can, with the MacroBenchmark, you can still run like some UI tests. So for the example, this one, you've got recycler view benchmark. I will run that and just it's working with the if I remember, with the text text issue, text time, and so you can be quick doing some tests on something that is more on the UI part. And as you can see, you've got like some result that you can find that high, but just to have an idea, this one is like not even 1 millisecond. I think it's maybe it's when you got in the million of nanosecond, you are in millisecond right there. So it's very, very short. So this one is for the MacroBenchmark. I will show you the MacroBenchmark one. So, okay, the MacroBenchmark is in alpha. So it's not quite ready, I would say, to use that in production. But you can already play with that. So that's why I think I've got some issue with the imports. And actually, just to let you know, if you fix and add the GUnit to your class path, so it will not be read anymore, but your test will not work anymore. So just leave with some error your code and just run the benchmark. So just to show you what's nice with the MacroBenchmark, sorry. Yes, it's 42. Yeah, we got just 2 minutes to show you the result and what's nice about that. So in this benchmark, I can show you the device. It's so looping through the startup of your simple activity. So it's just a dummy activity with this text view, and just looping from different startup mode in this example. So you've got, I don't know, sometimes you've got some issue just when you are resuming your application, when you are like following a deep link. So it's good to have a different way to test your launch. And I can show you there, it just specifies that it will run 3 times each iteration. So we've got three different startup mode to test, and you've got like 3 iterations for each. So 9 tests in total. We can see that it's much longer than the MacroBenchmark test. But as I was saying, it's like using functional test API. So it's like Android test, basically. I will just wait a little to have the whole report. So on the right, you can see the different startup time that we have with the different iteration, and you can see the obvious difference between the cold and the warm startup. And just wait to the hot mode to finish and just show you the link to your trace. It's almost 45. Come on, come on. So I think we almost finished. And there you've got the whole result, and you can, so if you want to see, oh, it was very slow at this point, not in this case for sure, because it's like empty activities, but you can click on the trace and show it directly in Android Studio. Okay. And you can like navigate in your trace. And there, actually, if I go on the activity, there, driver startup activity, I just added something to show you that you can add your own trace label to help you navigate through the code. So there I've got the activity on create label, and I know that I'm there, you know, I'm on the on create of the this activity when I check my trace. So it's a nice way to improve the legibility of your trace, and do it for your colleague also if you want to create trace for tickets and document it. Yeah, I would say that's all. We are like finished in time.